Hello everyone, this is Vijay and welcome to my YouTube channel. Today we will discuss a shorter method to find the particular integral when q of x is equals to e to the power of ax. So guys, before going to the today's session, subscribe to my YouTube channel and follow me in Telegram for more updates. Now let's moving to the today's session. General solution of given differential equation is a sum of complementary function and particular integral. Sum of complementary function and particular integral is called general solution of given differential equation. To find the complementary function, we write the auxiliary equation. What is the auxiliary equation here? F of m equals to 0. F of m equals to 0 is called auxiliary equation. By using this equation, we find the roots of the equation. Now let's see here. Roots of auxiliary equation and complementary function. If the roots are real and different, what are the roots? m1, m2, m3 are the roots. These are real and different roots. Then what is the complementary function? c1 e to the power of m1x plus c2 into e to the power of m2x plus c3 into e to the power of m3x plus so on. See the second one. The roots are real and equal. Here m1, this one is m3. Take this as m3. m1. So here two roots are real and equal and remaining are different. Then the complementary function is c1 plus c2x into e to the power of m1x plus c3 into e to the power of m3x plus so on. Next here third one. Here the three roots are real and equal. Remaining are different one. So m1, m4. Here these three roots are equal and real. Now let's see the complementary function. What is the complementary function? c1 plus c2x plus c3x square. c1 plus c2x plus c3x square into e to the power of m1x. c3x square into e to the power of m1x plus c4 into e to the power of m4x plus so on. Next is the fourth one. If the roots are imaginary and real, then what is the complementary function? E to the power of alpha x into c1 cos beta x plus c2 sin beta x plus c3 into e to the power of m3 of x. Here m3 is the real root. Next is the fifth one. The roots are imaginary and repeated and m5 is a real root. And the complementary function is e to the power of alpha x into c1 plus c2x cos beta x plus c3 plus c4x into sin beta x plus c5 into e to the power of m5x. Okay, this is the way to find the complementary function. Now let's see how to find particular integral of given differential equation. Okay, see here f of d of y equals to q of x. If q of x equals to e to the power of ax, here q of x in the form of e to the power of ax. In this method we replace d by a. In this method we replace d by a. See the step 1. What is the step 1? If f of a value is not equal to 0, substitute d equal to a in f of d. Substitute d equal to a in f of d, we get f of a value. What we get? F of a value. If f of a value not equal to 0, then the formula to find the particular integral is 1 by f of a into e to the power of ax. The particular integral is equals to 1 by f of a into e to the power of ax if f of a value not equal to 0. Next one, if f of a equals to 0. So the step 2. What is the step 2? If f of a equals to 0, then here two cases arises here. If f of a equal to 0, two cases arises here. So what is the case 1? What is the case 1? If f of d is in the form of d minus a whole to the power of n when n equals to 1, 2, 3 and so on, then what is the particular integral value? X to the power of n by n factorial into e to the power of ex. Okay. If f of d is in the form of d minus a to the power of n, then the particular integral is x to the power of n by n factorial into e to the power of ax. Now let's see the example here. See this one. This is a previous year question of CPGET entrance examination. Question number 23 in the year of 2020. So what is the question here? Find the particular integral of 1 by d minus 3 to the power of 3 into e to the power of 3x. 1 by d minus 3 whole to the power of 3 into e to the power of 3x. Okay, observe here, it is in the form of 1 by d minus a whole to the power of n into e to the power of ax. Okay, here what we observe, a value is 3 and n value is also 3. A value 3, n value 3. If substitute a value, n value in this formula, so what we get, the particular integral is, see this one, x cube by 3 factorial into e to the power of 3x. What is the formula? X to the power of n by n factorial into e to the power of ax. Here a value is 3, n value is 3. So what is the particular integral? 3 factorial means 6. So particular integral is x cube by 6 into e to the power of 3x. Now see in option here, option 3 is the correct answer. Now let's see the case 2. What is the case 2? If f of d is in the form of d minus a to the power of r into pi of d, d minus a to the power of r into pi of d, when pi of a value is not equal to 0, when pi of a not equal to 0 and r value from 1, 2, 3 and so on. So then what is the particular integral formula? If f of d is in the form of d minus a whole to the power of r into pi of d, the particular integral is 1 by pi of a into x to the power of r by r factorial into e to the power of ax. Okay. Next see this one. Okay, here if f of d is in the form of d minus a whole to the power of r into pi of a e to the power of ax, the particular integral formula is 1 by pi of a into x to the power of r by r factorial into e to the power of ax. See this one, if r value is 1, if r equals to 1, now what we get, 1 by pi of a into x into e to the power of ax. If r value is 2, if r equals to 2, what we get here, 1 by pi of a into x square by 2 factorial into e to the power of ax. If r equals to 3, then the particular integral is 1 by pi of a into x cube by 3 factorial into e to the power of ax. Okay guys, in next video we will discuss some more important results. Thank you.